Okay, guys. So let's get into it and let's document this. Okay. So this is macro defining the default size of the hash map. So, hash map keys. Right. We will have 100 keys at max. I think. Right. Buckets. Yeah. 100 keys. Okay, then we have type def, and okay, this is a pointer to a function for comparing keys. And this is pointer to a function for providing um, the for generating the hash, getting the hash from a key. It returns the unsigned 32-bit hash. Returns an unsigned 32-bit integer hash value. Okay. Buckets. Okay, dynamic array. Array for storing our keys and their values. Pointer to a function for comparing keys. Then we have pointer to a function for generating the hash. Okay, this is our hash map. Okay. Then this is our hash map, which contains the compare function, hash generating function, and what else? And a dynamic array called bucket for storing the nodes, I think these buckets will be storing these nodes with keys. And okay, I think for a unique hash, okay, we'll see how it works. Okay, then this is our single node, which is a pair of keys and values and also con- and also stores the hash code within it. Okay, then this is a function for traversing the node and displaying all the data associated with it. Okay, so function to create a hash map, function to create a hash map, function to create a hash map, right? Function to create a hash map with default, create a hash map, create a hash map, okay, and hash map, and you have to provide a compare and hash generating function for the specific data type that you wish to use as a key, right? Destroys the data in the hash map. Function to set/add a specific key value pair and function to get the value for a corresponding key from the hash map. Function to traverse, right? Function to traverse the hash map and you have to provide how each of the node gets traversed. Okay, then function to remove a key value pair from the map. Okay, let's see how does it implements. Okay, default compare function which compares the B strings. Default hash function which takes in a string value and generates a generates an unsigned unsigned 32-bit integer hash. Okay, and we have function to create a hash map. Okay, allocating compare. Okay, then buckets equals maps buckets dash and alright, so okay, if the values for the compare and hash is not provided, we stick with the default value, default functions, right? Okay, then here we allocate a fixed but how? Okay, here we allocate a fixed number of okay, here we allocate fixed number of let's say elements in the array buckets size of pointer. Okay, array create, we are creating, okay, the array pointer, any pointer, right? Okay, we allocate a fixed number of elements in the array buckets. These elements in turn will be pointers to other arrays. Okay, now we have set the end of the array equal to max of the array. This is done so that this is done as the number of elements we have to deal with are fixed, right? And since we won't be dynamically adding any new keys, I think it should hash 10. Okay. Since we won't be dynamically adding any new keys, we won't have to check if the D array is expanding or not, as we will not be pushing any new keys. Okay. Hashmap destroy, I'll get into it later. Yeah. We have hashmap node create. Okay. Function to create a hashmap node. Okay. Find hashmap find bucket, and bucket number equals to hash and default number of buckets. Okay. If bucket number should be, yeah, hash out equals hash out. Okay, so what we are doing is we are get, but okay. This function is the main. This function is the most important, as it is responsible for finding as well as create one. Creating a new bucket corresponding to a specific hash value, right? Multiple keys can have the same hash value, or maybe like hash mod, right? Multiple keys can have, right? Finding is creating new bucket corresponding bucket num. Okay, so hash equals 0. We get the hash and we create a new node with a specific hash, and then we hash in the node. Okay, this is relatively easy. Okay, the hash function, the function that generates the hash, is a bit complicated. We are taking XOR and we are adding XOR with, then we are adding it again. And then here we allocate a fixed number of. Okay, so for sorting, for storing our keys and their values. Well, it is not specifically a key, they are based on hash values. For storing nodes corresponding to their specific hash, right? Comparing keys, or okay, we'll see how it compare function works. Nodes corresponding to their specific hash. Which contains a compare function, which compares which contains pointer to compare function and pointer to hash generating function, and a dynamic array called bucket for storing the nodes corresponding to the specific hash. Link to a specific hash. Okay, this is also stores the hash code, so stores a unique hash code within it. Okay, choosing the node and displaying all the data associated with it. Data. Okay. Right. So function to set add a specific key value pair. Function to get the value for the corresponding key for the hash map. Right. This will just return the. I think this will return a D array. We'll see. Okay, hash map node create. Okay. So basic. Okay, this function is the most important as it's responsible for finding as well as creating a new bucket corresponding to a specific hash value. Okay, so where does it get the hash? Create hash. Okay, we store the hash map hash. Okay, I don't know if the hash. Oh, okay, so it calls the hash function and it generates. Okay, so we take the key. Okay, here we take the key and generate a 32-bit hash. Check number of buckets should be greater than or equal to 0. Okay, this defines the hash remainder. bucket and D array get. Okay, this is the index. Okay, so D array bucket, D array get map buckets. Okay, so hash out equals this hash. Okay, so it generates a index to the bucket it generates an index to the bucket to the D array within the buckets D array okay. So it generates an index to the D array within the D array and okay. Then we set the value of the hash out. Yeah, I think we provide the hash, right? Hash this, and we then set the hash here. Okay. Bucket and node. Can't create bucket. Hashmap get node. Node hash. Okay. Get node hash map hash bucket. Dear get try. Try 1. Right, hash map node array. Get if node equals match compare node key with this key equals 0. Then return I. Okay, so we get a okay. Right. Okay. It generates an index to the D array within the buckets D array. We are simply limiting the index to 0 index to 0 to 0 comma default number of buckets minus 1, right? In this case 0 to 99. This will ensure that all the key value pairs okay, so this will ensure that all the key value pairs reside within these buckets only. Okay, then we store this generated hash into the pointer provided. Now we find the bucket corresponding to the calculated index. If the bucket does not exist and the create flag is on, then we create buckets and then we create a new D array then we create a new D array and add it at the generated index. Okay. Now we simply return the pointer to the D array. Okay. This function helps to add / set key value to add key value pairs, or if the key already exists we add data to it. Okay. No. The function helps to add a node which contains the key value pair or if the node check hashmap node create hash check node. Okay, we create a node there we go, we create the node. Node create, we find bucket with the hash, then we simply bucket and then all right if the node with the or if the node to add, we simply add with functions to add a node which contains the key value node with a key value pair. Okay, so this will store the generated hash from the key. Okay, then we create a new bucket if the bucket does not exist and the create flag is on, then we create a new bucket, or else we simply would have then we create a new bucket if okay then we find slash create a bucket corresponding to the hash now we simply create a node with the given key value and store the generated hash. Okay. And finally push that value for multiple keys, right? Collision where multiple keys get node. Okay, hash is same and the key is also same, then we return the bucket array and bucket map dash compare map dash hash equals hash. Okay, so we have hash map node equals array get node hash, we have to provide the bucket and then we have to provide the key. Okay, so we check the key if both the keys are equal. Okay, so comparing keys, yes. Okay, so it does compare keys. I'm right regarding that. And then we get okay, and finally we push that value into the bucket. Okay, starting inline hash map get node okay function. We find the bucket key, if not bucket return null, node equals array get I, okay, return node dash data. Okay, say I have the same keys would have the same hash value, right? So keys must be unique, right? Keys have to be unique, but it does not check for that, right? It does not check for unique keys. Now we simply create a node with a given key value, store the generated hash, and finally push the bucket. Okay. Get. Okay. This assumes that all the keys are unique. Right. This assumes that all the keys are unique. But certain keys can have keys are unique. However, certain keys may share the same hash code. Okay. Here we traverse the array for a specific hash. Okay, if node of hash equals hash and key is equal, why are we comparing hash? We are already finding the value with the same hash, right? Okay, so Okay, so here we traverse the array for specific. Um, Here we traverse the D array which is provided and compare the keys and hash values, and simply return the index to that element in the D array at the end and -1 on failure. I++, I can try hashmap node bucket. Okay. Hashmap get hash key. Okay, so this hash is here, used for finding the node we obtain the bucket corresponding to the hash, right? Then we get the index of the node within that bucket. Now we obtain the node we obtained because the collision is handled by chaining. Okay, now we obtain the node from the bucket if it exists, and simply return the data associated with it. Okay, hashmap traverse map traverse callback. Okay, hashmap delete. Okay, read count. Okay. Traverse less than the bucket, this bucket. Okay, all right. Okay, so buckets of I, right? So we do a calc on this, right? Hashmap map calc. So this is by default null. Okay, then we create pointers, right? Pointers to D array create pointers to D array. This D array create hold on. Okay, so let me see. D array create. Okay, malloc, right? And then array content is calc. Okay, element size 4. What is size of? I assume as is with 4 bytes, 32 bits memory address. Okay, we need to go malloc on this, and then we go calc on this, right? And is 0 and else. Okay. Right, so it creates values with null, right? Bucket, all the values are null, and right, destroy function. Okay, traversing, read count, traverse CB. Okay, traverse need to should not be 0, and we return the RC, read count. Okay, if it is not, okay, if it is not 0, then return read count. I think it returns the error code. Traverse function. Okay, delete. Find bucket. Go with function. Function to function. Remove a node from the map. Okay. Get node. We free the node. Hashmap ending. Okay, it's not the last one. Swap it. Okay, so we simply push it to the end. Okay. Dear pop bucket. Okay, we get a size of hashmap node, right? Bucket size, void pointer, node for hashmaps. Alright. Data. Okay, it returns the data associated with the. Okay. The function to remove a node from the map. First, we will find the bucket associated with the hash. Then we find the node itself. Now we get the okay, now we get the node. Now we get that node from the bucket. Okay. Deallocate memory from that node. Okay. Now we get pop Okay, now we get the node which is situated at the end if the node we deleted and the node at the end was same, then it's okay. We simply overwrite the value as they are not same. We simply overwrite the value in the bucket with the popped note. Write the value in the bucket associated with the index of our deleted node with the popped node, and we return the data of the deleted node. Okay, so this is it. I don't understand the return count right now, and I think I get it. Okay, fairly easy. Okay, function to deallocate memory from the map. Okay. First we check for the validity of the map create. First we check for the validity of the map. Then array of the content. Now we loop all the 0 to 99 buckets loop through if the bucket exists. We free the data within that bucket. We free the nodes. Now we destroy that bucket. Then destroy the main bucket's array, and finally deallocate from the deallocate the map, deallocate memory from the map, right? As simple as it gets. F3. Okay. Initialization. Calc. Alright. So I think this is enough for now. I call it a day.